Are we not alone? Why can AI become a bridge between civilizations? Will artificial intelligence be the first to find extraterrestrial intelligence? Hello, friends. What if the first contact with extraterrestrial intelligence occurs not through astronauts or telescopes, but through artificial intelligence? While humanity argues about UFOs and the Drake equation, machines are already listening to space more attentively than we are. Perhaps they will be the first to hear an alien voice in the universe? Before we continue, like, subscribe to the channel and leave your impressions. Here you will learn a lot of smart and useful things about the cosmos, the unknown and unsolved. The wow signal, the Fermi paradox, and AI, how machines are changing the search for aliens. Decades of searching for extraterrestrial intelligence have hit a fundamental problem. Space is incredibly big and noisy, and Earth's interference only complicates the task. Traditional SETI methods are stuck in petabytes of data, but today a new, much more powerful player is entering the scene: artificial intelligence. Learn how machine learning sifts through petabytes of information, eliminates interference, and may soon give us our first real contact. Listening to space. On a summer night in 1977, a radio telescope in Ohio picked up something unusual, a narrowband burst of radio signal that lasted only 72 seconds. Astronomer Jerry Emmons circled it on a printout and wrote just one word in the margin: wow. Decades have passed, but the wow signal has not received a clear explanation. Researchers have plenty of versions: equipment failure, radiation from a comet, reflection of earthly noise. Recently, some scientists suggested that it was a violent splash that crashed into a hydrogen cloud, but there is no consensus. The popular hypothesis of a comet's hydrogen cloud in 2017 has caused a storm of criticism. New works suggest that a similar effect can also be caused by a star flare flying into a hydrogen cloud, but this version also remains controversial. There is a chance that wow is the closest that humanity has managed to hear from another civilization. Yes, weaker signals have been recorded over the years, but such a powerful one has never been repeated. The reason for the doubts is simple: two irradiators of the Big Ear telescope did not record the signal at the same time, which does not fit well with most natural explanations. This is the difficulty of searching for extraterrestrial intelligence. Space is deafeningly noisy, the Earth itself is full of interference, equipment malfunctions, and the chances of success are negligible. We are rummaging through an endless data stack where you can search for a needle forever. For more than 70 years, scientists, officials, and entire ufological communities have not tired of searching for evidence of the existence of aliens. Meanwhile, on Earth, researchers and enthusiasts collect eyewitness accounts, photographs, video recordings, and even radar signals about unidentified flying objects, which today are more often called unexplained anomalous phenomena. These are objects spotted in the air, water, or space. But the infamous wow supposedly came from the depths of the universe. Continuing to search for its source, scientists have connected entire networks of radio telescopes, listening to the whispers of space. But a new tool is replacing the usual antennas. Artificial intelligence, the same technology that underlies chatbots and image generators, is now directed outward. It is becoming our cosmic ear, capable of shoveling through oceans of signals and fishing out the weakest, barely noticeable deviations from them. Why have we always looked at the sky? From the most ancient legends to the latest space missions, people have wondered, what if the stars are inhabited? People around the world have told stories of celestial beings and of humans coming from the stars for generations. Western scientists have taken a different path: equations, calculations, hypotheses. In 1961, astronomer Frank Drake presented what was later called the Drake equation. This is a probability formula that allows us to estimate the number of extraterrestrial civilizations in our Milky Way galaxy whose technology humans are able to grasp. However, it cannot be understood as a prophecy with a specific number. The equation is more of a framework for thinking. There are stars, they have planets, some planets are suitable for life, some life evolves into intelligence, intelligence creates technology, and only a few civilizations remain visible long enough for us to detect them. In other words, this is not a count of the exact number of brothers in intelligence, but an estimate of how many worlds could support life and intelligence. The scale is staggering. The Milky Way contains hundreds of billions of stars. Even if a tiny fraction of them have habitable planets, the math says intelligent life is quite likely. And yet, silence. This mystery has been dubbed the Fermi paradox. The Fermi paradox is that the conditions for intelligence to emerge do not seem to be all that rare in the universe, but we see no one there. This is the contrast between the compelling evidence for life and our complete lack of findings. Does the silence mean that there is no one? Or have our instruments so far been too weak to notice our neighbors? The data problem and why is AI important? Looking for aliens is like trying to catch a single whisper in Times Square on New Year's Eve. Earth's airwaves are filled with our own technologies, satellites, Wi-Fi, radars, flying airplanes. The vast majority of candidates for signals turn out to be our own. And yet, AI systems trained on telescope radio signal patterns have already significantly reduced the number of false leads and at the same time identified strange anomalies that old methods simply would not have recognized. Classical algorithms help to clear up the chaos, but they act according to the rules. They look for a narrowband burst or a frequency that changes over time. As a result, they either miss unusual patterns or give millions of false positives. But in neighboring radio surveys, machine learning systems classify candidates for pulsars or radio interference with an accuracy of over 99%. That is, AI reduces the number by an order of magnitude errors. AI approaches the problem differently. Neural networks do not require clear instructions for each case. They learn to distinguish what normal noise looks like, and then highlight what does not fit into it. In other areas, this is what made it possible to find cancer in images before doctors. In relation to SETI, this means that AI is able to process billions of signals and highlight a dozen that are really worth taking a closer look. Signals that could have slipped through the cracks. In 2023, a team led by University of Toronto student Peter Ma used deep learning to review 480 hours, about 150 terabytes, of breakthrough listen data collected from 820 nearby stars. As a result, they found 8 interesting signals that traditional methods simply missed. However, during subsequent observations, none of them were repeated. But the very fact that AI saw something that people had not noticed for decades is impressive. Today, the Parallel BL program, the South African Meerkat telescope, scans nearly 1 million stars in densely populated areas of the sky, and AI sorting is essential. Other researchers are using AI to filter out human-created interference, literally cutting through the static and leaving only the rarest anomalies in sight. Today, AI brings together information from different spectra, picking out faint, unusual traces that humans would consider noise. In other words, AI helps us do more than just hear. It helps us see. Are aliens real? The honest answer is, it depends on who you ask, a theologian, a scientist, or an eyewitness. The truth is, we don't know. No government agency has ever published confirmed and irrefutable evidence of extraterrestrial intelligence. Yet the lack of evidence says more about us than about aliens. We've probably only combed a tiny fraction of the possible cosmic haystack where signals may be hiding. Can we be blamed for not having found life on other planets yet? Astrobiologists think in terms of probability. A 2020 study, for example, claimed that there could be at least 36 active intelligent civilizations capable of communication in our galaxy, though most of them would be thousands of light years away. Others believe that complex technological life is incredibly rare, requiring an almost miraculous coincidence of conditions, as on Earth. Just imagine, 36 civilizations, simultaneously thinking and communicating. Meanwhile, the UFO and NAIA reports that fill the news feeds remain intriguing but unproven. NASA's 2023 review says there is no evidence to support an extraterrestrial origin. The U.S. Department of Defense, in its historic 2024 AARO review, also stated that the country has no alien technology. The existing data is too sparse to either prove or disprove an extraterrestrial origin. One thing is certain, AI can analyze such cases much more strictly, cutting out human errors and natural phenomena from the truly abnormal. For ufologists, silence is not the same as loneliness. Perhaps this is just a sign that until now we did not have the necessary tools. What else can AI find? The next decade could be a watershed. Imagine an AI picking up a repeating radio signal from a nearby star that is too clear to be natural. Or noticing traces of industrial chemicals in an exoplanet's atmosphere, pollutants that only technology can create. Or perhaps picking out a star whose light is fading in a strange, rhythmic way, as if giant structures were circling it. One day, an AI might point to a narrowband transmission repeating from the same patch of sky a signal that nature almost certainly could not have created. Or discover an exoplanet emitting excess infrared waste heat that neither geology nor the star's light can explain. Such a signature could point to massive energy harvesting technologies. Of course, none of these scenarios are guaranteed. But AI gives us the ability to consider such possibilities seriously, an ability we've never had before. For alien enthusiasts, this is truly fascinating. The universe is now scanned not only by human eyes, but also by intelligent machines capable of hearing what we cannot. What would it mean to meet aliens? There is an old saying, be careful what you wish for. If contact did take place, even if it were a subtle but unmistakable signal, the consequences would touch every area of human life. Science would change overnight. The very fact of the existence of another form of intelligence would prove that life is not unique to Earth. Intelligence is not a random whim of evolution. Biologists, physicists, astronomers would receive mountains of new data. Politics and security would shudder. Who would speak on behalf of the Earth? Should nations cooperate or compete in the struggle for control of the discovery? The United Nations has no binding mechanism for first contact, but there is the Treaty on Principles governing the activities of states in the exploration and use of outer space, including the Moon and other celestial bodies. However, in essence, this is a treaty on the non-deployment of weapons and the prevention of a colony race, rather than a strict instruction on who has the right to speak on behalf of humanity. But the key here is that these recommendations have no legal force. Some experts believe that secrecy will prevail in the early stages. Governments will assess the risks before sharing news with the public. Religion and philosophy will also be under attack, although they will not be destroyed. For some faiths, the discovery of alien life will be a theological puzzle, for others, a confirmation of the diversity of existence. And for indigenous traditions, which emphasize kinship with space, respect for all living beings and even have legends that man came from the stars, this will be a long-awaited confirmation of ancient knowledge. Why is AI changing the rules of the game? AI can help us not only find our fellow intelligent beings, but perhaps avoid their fate. AI gives the search for extraterrestrial intelligence two crucial advantages: scale and rigor. Scale is the ability of deep learning systems to process and compress petabytes of telescope data into short lists of signals that scientists can actually test. Rigor is the reproducible procedures and transparent methods that minimize human error and bias. This ensures that the results are verifiable and reduces the risk of confusing interference or noise with a genuine discovery. Together, these qualities make SETI both more efficient and more reliable. So is there anyone out there? AI hasn't found its intelligent brothers yet, but it has already proven that we haven't looked for them well enough. It doesn't just speed up analysis, it opens up new search methods, be it hypothesis generation or something else. Perhaps the first signal from another civilization will be a barely noticeable splash that only a machine will notice. And then it is artificial intelligence that will become the bridge between the two forms of intelligence in the universe. Like, subscribe to the channel and leave your impressions. Here we learn smart, kind and eternal.